Welcome to qnawire.
So let's suppose C, f of C, is an inflection point of our graph or of our function of f of x. And so what we're going to do is, since we know that our point C, f of C, is a inflection point, we can use the fact that the concavity is going to change at x equals c. So this means then concavity changes at x is equal to c. And wherever the concavity changes by the first derivative test, so you can say by the first derivative test, our first derivative, f prime of c, will be a local extrema. That means it will be either a local max or a minimum value for our first derivative of f. And since our first derivative of f has a local extrema at this point c, we can say that by Fermat's theorem, which just says that a local minimum or maximum of a function f means that the derivative of that function is 0 at that point. So if this f prime of c has a local extrema at that point c, that means the derivative of f prime, which would be f double prime of c, is equal to 0. So the derivative of f prime of c is equal to 0, and this is just the second derivative of f is equal to 0 at c. So now we have proved that if c f of c is an inflection point of f of x, then that means that the concavity changes at that point, which means that our first derivative is going to have a local extrema there, a max or a min, which by Fermat's theorem means that our second derivative is going to be equal to 0.